Hi everyone, I am Yamini, Department of Computer Science and Engineering, SNS College of Technology. Welcome to this session on separate chaining in hashing, part of Unit 4 in the data structure course. In this video, we will explore how separate chaining works, why it is used, and how it helps resolve collision in hash table. Introduction to separate chaining. Let's begin with a quick overview. Separate chaining is one of the most common technique used to handle a collision in hashing. When two or more keys are mapped to the same index in a hash table, a situation known as collision. Separate chaining solves this by storing all this key in a linked list at the index. This ensures that no data is lost even when multiple keys share the same hash value. Let us recall that is, let us recall about hashing before driving deeper. Let's quickly recall the basic of hashing. Hashing is the process of mapping a large data sets of variable length into smaller in a fixed size values using a hash function. The hash table is the data structure used to store this value. However, collisions are inevitable when two keys hash to the same index. And what it's where technique like separate chaining comes in. What are the topics for discuss in hashing? That is hashing, separate chaining, collision, and application. Next one, a problem of collision. That is, a collisions are unavoidable. This is known as a birthday paradox in hashing. As the number of keys increases, the challenges of two keys share the same index rises diagrammatically. These collision solve down operations tuning an identically constant time big O of 1 operation into big O of n in a worst case. That is why it's important to use an effective collision resolution method. This is a diagrammatical representation of a problem of collision. Next one, that is an in separate chaining. Each index in a hash table contains a pointer to the linked list. When a collision occurs, the new key value pair is simply added to the linked list at that index. During retrieval, we hash the key to find the correct index, then traverse the linked list to locate the key. That is, in this ideation stage, we brainstorm way to manage a collision efficiently. One simple and efficient idea is to use a linked list at each hash table index. This design allows inserting, deleting, and searching without losing any data. It's fixable, memory efficient, and easy to implement. Next one, prototype, that is an implementation detail. Let's look at the implementation. Each slot in a hash table pointer to the head of the linked list. When inserting, we create a new node containing the key value pair and attach it to the linked list. For retrieval and deletion, we traverse the list at that index until the matching key is found. Next comes testing. We insert a multiple key to ensure that the collisions are properly managed. We verify that the collided element are stored in a correct linked list. Then we test the search, insertion, and deletion operation to perform that no data is lost or overwritten. Next one, applications, that is a real world use case. Separate chaining is widely used in real world system. For example, including database indexing for faster data retrieval, caching systems that store frequently accessed data, and associative arrays or dictionary in programming language. Even network router use hashing to quickly look up routing information. Thank you.